Hi and Assalamualaikum. My name is Nurhanisah binti Muhammad Tamizi, and today I will present Big Data project. The title is Manipulating Big Data with MapReduce in the Hadoop environment for Inverted Index. For the introduction, the rapid growth of digital data creates significant challenge in terms of storage, processing speed, and scalability. Traditional single machine processing is no longer sufficient to handle big data efficiently. Hadoop addressed this challenge by enabling distributed storage and parallel processing across multiple nodes. Using the MapReduce program model, large datasets can be processed efficiently and reliably. In this project, an inverted index is implemented using Hadoop MapReduce to enable fast and efficient text retrieval. Next, for the problem statement for this project is sequential word searching across multiple files is time-consuming and inefficient. As the size of data increases, the processing cost also grows significantly, making this approach impractical for large-scale datasets. Without an efficient indexing mechanism, fast and scalable text retrieval become difficult. Therefore, an efficient indexing approach is required to support quick and scalable text search over large volume of data. Next, there are four objectives for this project. For the first one is implement an inverted index using Hadoop MapReduce. The second one is understand mapper, reducer, and driver roles. The third one is analyze distributed processing of large text data. And then the last one is evaluate correctness and effectiveness of output. This section presents the literature review related to Hadoop MapReduce and inverted index implementation. According to Dean and Gimawat 2008, MapReduce is designed to process large datasets in parallel by distributing tasks across multiple machines, which improve efficiency and scalability. The inverted index is commonly used as benchmark application to demonstrate MapReduce capabilities in large-scale text processing. Previous study also shown that MapReduce-based inverted indexing scale effectively for search and document retrieval systems. In addition, Hadoop provides built-in fault tolerance and scalability, which ensuring reliability and efficiency data processing in distributed environment. The source for my project is from GitHub MapReduce example, and I use two types of file. For the first one is sample 1 with the line I love big data and finally AI. For sample 2 with I love hello world and finally AI. These files are in text and both included repeated and unique words. For the methodology, the system was implemented in Linux environment using Hadoop version 3.4.2, running in pseudo-distributed mode. The program was developed in Java. The inverted index program maps each word to the document in which it appears and count the frequency of each word per file. The final output is structured to support efficient search and text retrieval application. In this slide, I will explain about MapReduce program flow. Here is the diagram for the program flow. Firstly, the input text file stored in HDFS are first processed by the mapper, where each line of the text is read, tokenized into individual word, and emit as intermediate key value pair in the form of word and file name. Next, Hadoop automatically perform the shuffle and sort phase, which group all intermediate data by key so that the same word from different files are sent to the same reducer. The reducer then aggregate the result by collecting all files associated with each word and counting their frequencies, thereby constructing the inverted index structure. Finally, the complete inverted index is written back to HDFS as the final output. This slide explains the MapReduce processing flow used in the inverted index program. Firstly, the mapper phase reads the input text file line by line, split the line into words, and convert them to lowercase, and associate each word with its source file name. These word file pairs are then passed to the reducer phase, where identical words are grouped together and their frequencies are counted for each document using a hash map. Lastly, the driver phase configure and control MapReduce job by setting the mapper and reducer classes, defining the HDFS path, and submitting the job execution. The technical implementation of the inverter index program follows 6 main steps. First, Hadoop services are started to ensure HDFS and yarn are operational. Second, an input directory is created in HDSF to store the text file. Third, the sample text files are uploaded to the directory so Hadoop can access them. Fourth, the Java program is compiled and packaged into jar file for execution. Fifth, the MapReduce job is run using the Hadoop command, which executes the mapper and reducer phase across nodes. Finally, the output is viewed in the HDFS, showing the word map to their respective file along with their frequency count. This is the result from the Hadoop MapReduce Inverter Index program. It shows that all words are accurately mapped to their corresponding document with correct frequency count. Both repeated and unique words are handled properly. Upon analyzing the output, we can see that the mapper successfully tokenized the text and tagged each word with its file name, while the reducer aggregate and count these occurrences accurately. The final inverter index structure enables fast keyword-based search, removing the need to scan every file sequentially, which demonstrates the program's efficiency and correctness. This is the output of my inverter index program. Each line shows a word from the input file, followed by the file it appears in and the number of times it occurs in each file. For example, the word AI appears once in both sample 1 and sample 2, while big appears only once in sample 1. This output confirms that mapper correctly extract word and their file name, and the reducer accurately count the occurrences. In conclusion, I successfully implemented an inverter index using Hadoop MapReduce. This demonstrates efficient distributed text processing, and it is very suitable for scalable search and retrieval tasks. It is also served as a foundation for advanced big data application. That's all from me. Thank you.